Hi. Today I'm going to do something a little bit different. I really liked that there was a student who emailed me and they asked to kind of go over the specific handout from their econ class, and I really like that the student reached out to me. So I want to put my email address down below in the description below, because that's what I want to be here for, right? I want to be a resource along with the information that your professor already provides you. So I really like that, and I'm going to go over some of the specific problems here. Some of them I've already covered in my previous video, so I just want to go over these specific ones. So yeah, thank you. Like, keep them coming. I would love to work on these problems. My summer just started, so I would love to get productive that way. So all right, here the question asks, Anne is always willing to trade y for x at a constant rate. Specifically, she's always willing to trade, i.e. give up, 2 units of y to get an additional unit of x. So this is like our definition of what a marginal rate of substitution really is. It's basically just saying that a marginal rate of substitution means the change in y, right? How much you're giving up y to get an additional unit of x. That really is what marginal rate of substitution really is. Okay, so when you're seeing like, okay, Anne is always willing to give up 2 units of y to get an additional unit of x, that really is the definition. 2 units of y, 1 unit of x. So the MRS is 2 over 1. Okay, and so part A asks, okay, draw a picture of several of Anne's different indifference curves, right? Indifference curves, when you're thinking indifference curves, okay, that's MRS, that's marginal rate of substitution, that's willingness to give up y to get an additional unit of x. Okay, that's what I'm thinking. So for my x and y, for my graph here, I have my slope of 2, right? Slope of 2. And one thing that you'll probably know in class is we tend to not really care about the signs. We're always going to look at the absolute value because we all know that it's going to be a negative value. We just know, and so it just makes our calculations much easier if we just assume that it's the absolute value of the slope. So yeah, here's my negative 2 over 1, negative 2 over 1. And I had 3 lines. You can have 4 or 5, but at least 3 would be nice. So that's your indifference curve. Also, we see that constant rate right here, right? That's how you know that my lines are straight. That's how you know that my lines are straight. If this was not constant, if this was like a diminishing marginal return, then you would see a little curve, right? You would see curves. This is not like that. All right, here it says make up a utility function that exactly represents Anne's preferences. Here, what I see is, okay, I know that here's my 2 and here's my 1, right? I look at it this way, and I say, okay, I know this is basically just backwards, like, right? You're thinking backwards. First, we had our utility function, and we could just pinpoint our coefficients and make that our MRS, right? Perfect. But here, we're kind of going backwards, right? Now, think of it like when I was approaching this problem, I thought of it like if you've taken calculus before, you know that what we did with the coefficients, it was just taking the derivative, right? But now that we're looking back, now that we're like reversing our steps, think of it as an antiderivative, right? Think of it as an integral. So I would just add, like when you're taking the integral of 2, right, a constant, you're just kind of multiplying by an x, right? So that's why I got my 2 times x. Okay? And here, when you have another constant here, it's just a y, and it's just a 1. You just put that other like variable in when you're taking the integral. So you're just taking integral of that constant. So that's why I got my 2x and y. And now, if you want to check your work, right, look at it. Look at the coefficients in front. You can see the 2 in front. You can see the 1 in front of the y, right? This is a 1, this is a 2. And you see, okay, when I'm taking the MRS, I get 2 over 1. Oh, okay. I get 2 over 1, and that gives us our 2. That gives us our slope. Oh, great. my negative 2 over 1. Again, the negative doesn't really matter here, and I got it right. So yeah, you can take it like the integral way. You can just add that variable in, right? Because you're taking you're integrating a constant, so you're just multiplying it. Or you could just look at the numbers and be like, okay, how do I get my 2 over 1? What do I do? How do I put the coefficients in so that I can get that 2 over 1 at the end? Or a 4 over 2, or like a 6 over 3, blah, blah, blah. Anything that gives us a slope of 2. So the next problem is, I think I really like these problems because they kind of go over the different types of preferences there are. So for part 1, it says hot dogs and chilies, right? The consumer likes both and has a diminishing marginal rate of substitution for hot dogs for chili, right? So because we see that diminishing marginal rate of substitution, we know that it won't be a constant indifference curve. It won't be like a perfect substitution kind of a curve. It'll have those curves, right? It will have these curves, and that is what your first one will look like. And here I put my hot dogs on the x-axis, chili on the y-axis, because diminishing marginal rate of returns, right? We're having less and less. The slope is getting smaller and smaller as we get more and more hot dogs, right? The slope is different, higher here, and it's getting smaller and smaller. Okay, so part B. Sugar and sweet and low, right? The consumer likes both, will accept an ounce of sweet and low or an ounce of sugar with equal satisfaction. So when we see this equal satisfaction, okay, so I'm trying to just, when you're approaching these problems, I think that you should highlight those keywords that really differentiate between one graph and the other. So really highlight those problems, these words, right? Equal satisfaction, consumer likes both, so that's great. What does that sound like? That sounds like a perfect substitution to me, right? Equal satisfaction, that means I can either take sweet and low or sugar, it doesn't really matter. And so that's why we're going to have these straight lines, right? Also, I forgot to mention the preferred, right? The preferred, the arrow, where is it going? How do you know that it goes to the up right corner, right? I like to think of it as vector, like just think of it as vector multiplication and stuff. So I would do, okay, I prefer a lot of sweet and low. That's why I'm kind of increasing that in the graph, right? Also, I also prefer a lot of sugar. When you're doing the vector, when you're kind of connecting the vector, you see that our preferred line is going to be coming in this way, right? You can review a little bit of vector and watch other videos, quick videos, but this is what it looks like, right? You're connecting this endpoint or this start point to this endpoint, something like that. So that's where the preferred ones come in. Okay, so part 3, it says peanut butter and jelly, right? Whenever I think of that, okay, I think of complements. They go together, right? Left shoe, right shoe, perfect. Okay, so here, this is what our complement graph looks like, okay? And the preferred is also the same. We're preferring in the same angle as the other ones as well. And it says that you prefer 2, right? 2 ounces of peanut butter for every ounce of jelly. That's where my 2 comes from. Okay? So this is like 1/2, and then that's our slope, right? That's our little slope right over here. That was supposed to be straight. But this is a complement good. These are perfect substitutes, and this is just a diminishing marginal rate of substitution. Okay, so part D asks nuts. Okay, which the consumer neither likes nor dislikes, and ice creams, which the consumer likes. Okay. When I see, okay, neither likes nor dislikes, I think of, oh, nuts are neutral goods, right? I don't really care about it. I don't really care about if I have a lot or a little. I don't really care. So when I say that, I put my nuts on the y-axis, right? And I do not care. I'm like neutral about it. No matter how much of ice cream that I have, I will not care about how much quantity. I can have a lot of nuts. I can have a little bit of nuts. I would not care about the quantity. That is the neutral good. And also the preferred is only going to be to the right because I only care about a lot of ice cream. So that's the preference angle. Finally, we have apple and liver, right? Livers the consumer doesn't like, and the apple the consumer likes. Here we have a good good and a bad good. Okay, so our liver is our bad good, and our apple is our good good, right? We want more of apples and less of liver. So here is what our graph would look like for a good good and a bad good. Okay, I put my liver on the y-axis and apples on the x-axis, and to find out, what's preferred or not, think of it this way again, right? I want less of liver. Let's be straight. Less of liver, okay, but more apples. Less of liver, more apples, right? Now I'm connecting my starting point to the end point, and my preferred angle would be this. Oh, okay. You get the point, right? It would be going that way, and that's what my graph shows. So yeah, work through these problems again, highlight those keywords, and you will be set. So, thank you.